Okay, I think we are rolling now. So if you had tuned into the previous one, then you may remember where we were at. We were in the process of prioritizing how this default unit is actually going to be implemented in sort of the decision tree of what unit symbols get displayed. So I'm going to go back to sharing screen now. And I've got this URL at the top here. If you wanted the background information on Forallpeople, sort of what we're doing here, there's a little sort of page that I put together there for you to answer sort of basic contextual questions. Let's maybe zoom in a bit. There we go. All right, so last week we had in this get default unit. That's what we implemented here. And what the get default unit does is it looks for a one of the elements in these environment files here, and it looks to see if it has a default attribute on it, and if it does, then it takes that unit as the default unit in the event that the full factor and dimension match does not check out. So if there's no dimension match anywhere in here, then you're just going to see the unit displayed as SI components. If there is a dimension match, then, and that dimension does not have a factor associated with it, then that will be the derived unit. That's what you're going to see. But if you've got a defined unit, a unit that's defined by the SI unit system, but not a part of the SI unit system, like pounds and kips, then that has a dimension and a factor associated with it, but the factor can get sort of scrambled as you do multiple operations. And if you wish to remain in your defined unit system, you can set one of these to be a default value. So you would do that by just adding to your units environment this here, default true, like that. And now this would be anytime there's a dimension match and there is a factor associated with it, the idea is that then this will be but the factor does not match, then this will become the unit that's displayed. That's the big idea here. Now, where we left off is sort of actually putting that behavior into the sort of process here, the decision tree process of what unit to display. And that all comes down and it gets decided in through repr template is originally where it goes, but then it comes down to evaluate dims and factor here. And then that's where we return a symbol and a Boolean which indicates to us whether or not this symbol is qualified or is appropriate to apply a prefix onto. For example, newtons can have a prefix of kilonewtons, but pounds can't have a prefix of kilopound. That would be a separate unit that we call a kip. So, which is also defined separately in the environment. So let's see, where did we get the definition here of evaluate dims and factor? I'll do my F12, and that will bring us to this physical helper functions.py. And then we have the definition here. Now here's where we left off, and I made it out here. You're trying to figure out how to prioritize between defined, derived, and default units. Once this is done, this feature should be fully implemented. I say should because we've already implemented this function here to check for default units, and then we've also written some unit tests for this function here too. So here is what I had to think about. How is this behavior going to work? So is it going to only apply to defined units? So if you're working in the US customary or imperial system, imperial, of course, not being entirely defined by SI units, it has its own sort of parallel definitions that are roughly equivalent to definitions in the SI system. But if you are working in either US customary or imperial, then this is kind of where this default unit is the biggest pain point. That's what the default unit sort of solves, is when you sort of your factor doesn't sort of check out, but you want to stay in your defined system. Now, derived, if let's say you are working in some series of calculations in some context and you wanted all of your, say, forces to always be in meganewtons instead of never in kilonewtons, then in that case there's it's kind of a harder question, is because does the user want to have the ability to have the unit get displayed in whatever appropriate prefix there is, or do they want to be able to override it so it will always show up in, say, meganewtons or kilonewtons or plain newtons? I'm kind of on the fence about this one. So what I've come to right now for this current implementation is that the default unit will only apply and only affect the defined unit matches. So in the event that there is not a defined, there is a dimensions match, but not a factor match for defined, but there is a derived match, then it will default to it will look to the default here to see if there is also a defined match. Defined meaning it has a factors attribute in the dictionary, or a factor key in the dictionary. So I think that I think the easiest implementation, and also I think the least surprising implementation, I think just working with the defined units the default only affecting the defined units would be kind of the best way to go about this. Because there's just sort of too many if, ands, and other sort of cases to consider when we sort of default a prefix onto a defined unit or a derived unit. But also the other context about derived units. Let's say you wanted your what would that unit be? That's kilograms meters squared per second squared. That unit, what would that be derived? What would that be displayed as? What would that definition be? That would be for a moment, so say Newton times meters, or it could be a joule, right? And so if you were working in a units environment where you could be working either with torques or energy separately, then it could get confusing. So in that case, the having this default unit to go to either joules or Newton meters could be beneficial, but I am going to just put that as an edge case right now and just ignore that because it's easier to ignore it. So, and I think the feature, the majority of people that want this feature are working in a defined unit system and want to be able to stay in their defined unit system instead of getting kicked over to SI units. So that's the decision I made. That's how we're going to do it. So and then we'll release it. And then if there are issues on GitHub saying like, I want to be able to use it this way, then we'll consider what those use cases are and rely on those issues and the people in those issues to comment on how they want it to work for them to guide how we will implement it. I don't know the best way of doing this. I just know the way that I want to use it. And but the idea is that there's more than just me out there. So we'll start simple, get more complicated. So how is this going to actually work then? Well, let's do this. I think we might need to write a helper function here to check and compare a defined and default unit. So that's one thing I think we need to do, is to decide whether to use the defined or default, or rather the derived or default, because if there's a dimensions match in defined and a dimensions match in derived, it will choose the defined. If there's not a factor match, then it'll go to derived, but we don't want it to go to the derived. We want it to go to the default. So that's, I think, the key here. Now, there's all this other logic here that is not related to this decision here about which one of these three to use. So I don't want to have to muck about with this logic here because I don't want to break anything else in the meantime. I want everything to just work exactly the same, except now it's going to be checking, it's still just going to check between defined and derived and single dim. So this decision tree only considers defined or derived or single dim as sort of the conditions here. I don't want to mess with that. So what I want to do instead then is I want to kind of like, if let's say if defined is not found, this is an empty dict when there's no match, and default is found, and default has a factor associated with it, then I want to make defined, I do like defined equals default, you know what I mean? So that way I'm just overwriting the value of defined, and then I don't need to worry about the rest of this decision tree, because now defined is a hit, and then it takes this path here through the rest of the decision tree, and everything else just works the exact same. So if I kind of add my logic on top and adjust how defined and derived are those values are assigned, then I can put my second layer of logic on top of the existing logic and not break and change the existing logic, because every part of the logic in this library, it was thought about for a very long period of time. And in order for me to go back through it, I'm going to have to sort of like dig into it and sort of do that. So I'm going to sort of add a layer on top and then leave everything else. Now, that may not be the best decision, but it seems to be the best decision right now. So that's what I'm going to go with. So what is this going to look like? Well, let's just start writing out some logic and then just get a feel for if we want to break this out into a separate function to go through the logic here. So let's see. I think I'm going to say like this. Okay, if defined, then we'll say, okay, so if it's defined, let's say there's it's a match for the factor of pounds and the dimension of pounds. I want it to come through. Do I want it to come through in pounds, or do I want the default to always override it and always change it to kips? I feel like I don't want to override it always. If I intentionally wrote something in pounds, because the only way pounds are going to come through is if I wrote something in pounds and then I did like pounds divided by foot times foot or something like that. That'll, cancel the foot out and I'll get back to pounds. So if I input pounds, I want to see pounds. So if I input pounds specifically, then that's, I think, what I should get. So I'm going to say if the defined is not found. So that will say if not defined. Let's deal with this path first. If not defined, meaning an empty dictionary, and default, if not defined, and then default. Now, what's the order of logic here? I believe that not is going to come first, and is going to come last. But let's remove ambiguity also for the reader, who may not know exactly the order of operations for logical operators. If not defined, we'll put those in parentheses, and default, like that. And then we'll say, let's put this all in parentheses. Again, this may not be necessary, but I think it just sort of makes the process of logical evaluation in my mind easier. And default, and factor in default, because the default unit, let's go back to an environment here. So if this default unit does not have a factor, let's say somebody made Newton's the default unit, then if someone made Newton the default unit, then this behavior isn't going to, the fact that they indicated that is not going to affect anything in the logic of the software. I think that that's a good decision, and we will document that so that way it's clear. So if not defined and default, and factor in default, so we want to make sure that there is a factor key in this little sub-dictionary here that we get. Oh, except what's the dictionary we get? It's not just this, it's this and then sub-dictionary. Right, so I need the symbol or the name that comes out of it. So in order to get to the sub-dictionary, I need to get the values. So I can just use dot values, and that will give me the sub-dictionary dot values 0, because I'm never going to have, it's only just one dictionary. All right, so I need to jump into that dictionary. I'm not going to try and get the key because I don't have an obvious way of getting the key right now. So I'm going to have to access the values and assume that the values consist of only one dictionary. So we'll make that, let's say, we need to get to the values. And so we'll say, let's see, dot values, and default dot values, and the values is the dictionary. So, but that's going to be an iterator of the dictionary. So we need to get the first value out of it. Now, off the top of my head, I can't remember if I can just index into the values like that. So I'm going to pull up Jupyter Lab here and just confirm for myself if that is true or not. So I'll make a dictionary, call it R, and then we'll say A, and then 1, like that. And now we'll do r.values 0. Nope, it's not subscriptable. So that means in order to subscript it, we need to either iterate through it. So we could do, let's see, can I iterate through next like this? Nope, not an iterator. So I'd have to either iterate it or throw it into like a list. So there's the value of the value. So if I wanted the values to be a subdictionary here like this is what I'm getting. 3. Oops, changed view there. I didn't mean to do that. There we go. Okay, so let's see. That's now my values, get my code cell back, take out this business, run that. So there's my value. So I could do next iter values. I could also just throw this into a list and subscript it, but I don't need to store it in memory, but it's also very small. So, I mean, 6 of one, half dozen of the other, not a big deal. So let's do it, say, simple like this. And if it does not find anything, then but we should be able to, we'll always have a value here because we have already checked to see if default is truthy. So that means it's going to have a dictionary at the very least. And so if we're going to go through a list of the dictionary here, let's go through if we had an empty dict, what do we get when we do values? Stop iteration, but what if we did list 0? Then I think we might get an index error. So let's just do a check. Yeah, index error. Either way, we're going to get some sort of error generated. So the values always has to be there. And so maybe we want to have some sort of description here, because if someone just ran into that, then it's going to look really wonky. So let's just deal with that later, though. Okay. If not defined and default and factor in default, then defined equals default. That's basically the logic we're trying to implement here. I think that does the behavior I want. So let's try this quickly. We'll save it and let's open up Jupyter Lab and just give this sort of a test drive and see how that behaves. So I've got these values here. Now I didn't do auto reload, so I'm going to do auto reload now. Load extension, auto reload, option 2, restart my kernel, run the magic as the first cell to get auto reload working. And now I don't need to restart my kernel every time. Let's take this out. Okay, all right, so right now it's, I believe I'm not seeing the behavior that I want here. So let's see, I've got A is my pounds, right? A divided by B. That will give me pounds per foot because that's defined in my unit system. And then A divided by pounds times C. And now I'm introducing the factor of inches into this. And so a foot factor times an inch factor is not going to come out. So I'm going to get something in newtons. This is where it falls back to a derived unit that was found in the environment. So, but now I want it to default to pounds. Now, why don't I see it? Probably because I don't have pounds defined as a default in my environment here. So let's go ahead and just manually add this in. Okay, it's showing me a little squiggly here because you can't have a trailing comma in a JSON file, just handy FYI. And default, true. Oh, and you can't, this is Python true. In JSON it's JavaScript true, which is lowercase. Oh, and no trailing comma. So I'll save that and then go back to, now I can't remember if this is going to, I'll rerun the si.environment. I think that's what I need to reload the environment there. Ah, still not running. Okay, so I'm just gonna do a quick confirm, even though I've got auto reload going, see if it comes through. Okay, so it's not coming through. So that means there's something that is not right. Now I can't remember if it's in here or if it's in the function here. So let's just do get default unit. Let's go look at the definition there, make sure that I did the, look at this, if default in define match lowercase. Let's just make sure that I don't have to deal with this uppercase lowercase crap. So I'm going to say in define match dot lower. There we go. So let's save that. Now let's try rerunning. Oops, open up the wrong browser in the other window. Yeah, there we go. So now let's reload the environment. Hey, all right, this is good. It means that something is happening. Okay, so it looks like I did the dot lower attribute on the wrong thing. So let's go back and see what I just did. If default in defined match. Okay, so let's do this. How about it looks like I need to deal with this. I have to do uppercase, lowercase exactly right. So let's do this as default. And because that is how all of the other unit definitions like attributes are defined here, right? I put default in like that in kilonewton. Okay, like this. So let's go through. So I've got one in kilonewton now, and I've got one in pound. So I've got competing ones. That's good. That's good. Let's just leave that in there for now. So let's go back. And let's run this again. Also rerun the environment. Hey, that's what I want to see now. Okay, so this is cool. This shows us two things. One, that it works. Two, it also shows us that when we have a competing default set to an SI derived unit, that it behaves like I want it to, in that it has no effect, because the default unit only comes into play when we are working with a defined unit, a factor that's sort of got dimensions in the environment and a factor attribute. So let's try this now with kip, which should come through in pounds. Okay, except 5.si.kip is not 12.5 pounds. Okay, so what's happening here? So right. So it seems that the factor is not, oh, right. So the factor, if I implement it this way, then it's not taking into account, but it should, because the magnitude, the value is the same, that value, right? So the value of that versus si.pound is completely different, right? By a factor of 1,000. So why is the value not being taken into consideration here? Because, let's see, the value, and then once the factor's applied. So what I'm expecting to have happen here is, first, everything should be applied. It should be what you see is value times factor, basically, and then with the symbol at the end. So what am I missing here? Let's see now. Okay, so get default unit. And now let's go into the derived unit, or no, let's go into the repr. Let's go into the repr template here, which is where it all starts. Everything happens from the repr template, and so that's here. So here we are, the repr template. This determines everything about. This is where all the computation of the library happens. Is when you go to actually display your unit. That is all the hard work. All the arithmetic is easy. The displaying the unit is the hard stuff. Okay, so what is happening here? So I'm getting so here we go. Symbol, prefix bool, evaluate dims and factors. So what comes out of this is the symbol and the prefix bool. That's the only thing. The factor goes into it as an input, and let's see how the factor gets used. Oh, I can't remember where we are. Let's just go use F12 again. Get to our definition. Evaluate dims and factor. So the get default unit. So now, all right, so the whole point of passing in the factor and the power and all that stuff is to get the unit definition. Cool. And so whatever is found is just returning the symbol and the prefix bool. And the prefix bool for a defined unit is always false. So defined equals default. Right. Okay, so I don't see why it's not picking up here then. I would think that once the symbol and the prefix bool, so this is going to give us our LB as a string, and prefix bool is giving us false. So let's go through the rest of the logic here. elif prefix bool and prefixed. Not prefixed. Prefix bool and dims original. Okay, so none of this is all checking for prefixing, which means all derived unit stuff. Format the exponent. Is there an exponent? Well, there's not in our case, but do we need to worry about that fact? Power is going to go, yeah, the power is just there to check to see if it's a linear multiple of some original vector units or component vector units. So format the units. If not symbol, okay, so we've got the symbol. So if the symbol is found, we have a symbol. And so we're going to go format symbol. And then that will give us back this, I believe this is a string here. So let's go take a look at what format symbol does. Returns a string. Yeah. So it just gives us this like whether we're repr template HTML, repr template LaTeX, whatever it is, it just sort of formats it correctly. So let's go back to init here. Okay, so then value is value times the float factor, and the float factor comes from the factor. I know what is happening. Okay, here's what it is. The factor is coming in from self.factor. And now when we assign a default unit, we're changing the factor. So what we're seeing there is the kip symbol with the pound factor being applied, I think. So let's see. Let's go just do a little print here. So we'll throw our little print in here and say, okay. So I'm going to put this under symbol prefix bool. So I'll say print f-string as symbol equals, and then I'll also put in factor, float factor. Do I have float factor up at the top here? Do I do float factor, or do I float at the bottom? And because a factor is a fraction, so in order to make it sort of easy to work with, we have to convert it to a float to change how the value is represented. Okay, so float factor is defined there. Let's just do that, float factor. Okay, now let's go ahead and go back and see what happens here. So we do the arithmetic. Oops, I think I must have restarted something. Let's just restart. Run the environment. There we go, no problems. A.value, and here. Float factor, and then let's look at the factor for kip. So A.factor is this. Let's float it. Okay, so this is the factor coming in, and then pound.factor is 1,000 times that, so 0.2248. And then this is the factor that's coming through as a result of like doing kip and inch and stuff, so it's off by a factor of 12. So if I did this times 12, yeah, that's what I'm seeing here. Boom. And 731 say, yeah, okay, so this appears to have the same level of precision here, but this factor is not defined in the unit system. So that's the factor that's coming through, and this is not what I want to see. So I need to overwrite the factor with the default. So now this guy only returns the symbol and the prefix bool. It doesn't concern itself with the new factor, and the factor is being always taken from the self. So whatever it has. So in this case, I need to overwrite the factor. So I need to get a new factor. How do I do that? So, and one way to do it would be to change evaluate dims and factor here. So it changes the return values. So now that may be like, oh, that's a breaking change. It doesn't matter because this is a private function. This is what this underscore here is. I have full license to change how these functions are implemented, and nobody should be using them. So I don't have to tell anybody that this has changed. So symbol prefix bool. Let's see, do I want to muck about with that? Let's take a look. Let's go to the definition. All right, so when do I need to return the factor? So the factor is coming in. That's handy because that means I can pass it through and nothing changes, except that I need to call float factor after this. And then I could also pass through a different factor. And the only time I'd be changing the factor is in this condition here. So, but then so I got default values. So I've got the subdictionary here. So let's break this out. So I'm just going to call this the default swap logic. Okay, so first off, I'm going to get this dictionary here. So default unit, I don't want to call it default. What would I call this thing? The default attributes is this guy, because I'm going to break this out because I want to access this again, yeah? So there, put that there. And now, so in factor in default attributes. And if it is, then I want to take factor out, and I'll say factor is now equal to default attributes factor. Let's do it like that. Okay. And now this returns symbol prefix bool factor. Now I don't need to do anything with the factor, but let's go. But it doesn't matter if I do. I'm just passing it through, so I get to just reassign it. So let's do this. I've got an old factor coming in, which is self.factor. So I'm not going to change this stuff. Let's just keep that. Except I don't need to do float factor right now because that's not used until later. So let's take this. So self.factor comes in. Okay, now this returns powers dims original, and I'll call it modified factor. And I'll just make a note to myself. Modified factor is either the original factor or the default, the new default factor if a default lookup was triggered. There we go. Okay, so that's that. Okay, so now I want to do factor equals mod factor, like that. Now the rest of the logic can proceed, and I can also just do this. I need to do float factor here, equals float the factor. Now, why am I just like writing over factor here? Because it's a pass-through. I'm not going to add a logic to check to see if the original, if mod factor equals the original factor, and if so, then go with the, or I don't need to do any of that because it's a pass-through. That logic's already been written. I don't need to write it again. I don't need to do that check again. So it's going to just stay like this. So we'll just overwrite whatever we had with whatever mod factor is. So that might be the same or it might be different, but it doesn't matter. If it is different, that's what I need. And now float factor is going to have that value. So let's save that and run that back. Oops, forgot to rerun it again. Okay. All right. This is good. Our code is running. Not enough values to unpack. Expected 3. Got 2. Okay, so I didn't do my logic completely right in this guy then. I didn't make sure that there, it seems that there's a path out of this function. No, there should be a path. There's always a path through the function. Factor is already defined. The only path through this function is coming out through this return statement, so there should always be a factor here. So what's the message saying? Let's see. We've got not enough values to unpack. Expected 3, got 2. Well, why did it only get 2? Powers of derived. Oh, look at that. I think I did the wrong function. Okay. Let's go back to init. Yeah, I did that wrong. Let's take this out. Powers dim original. Powers of derived. Evaluate dims and factor. There we go. Yeah, I did this to the wrong thing. There we go. Take this out. Here we go. Now I put it here. Oops. There we go. Oh, let's call it mod factor. That's what we decided it would be. And then this little note comes back down here. There we go. Save. All right, now let's run this business. It looks like I need to rerun the environment again. There we go. Cool. There we go. Now, 5 times 8 feet divided by 20, and 8 feet divided by 20 inches, it's almost 2 feet, so that's basically 4 point something. 5,000 divided by 4 point something, you should be, foreign change is about that. Okay, that seems right. So let's do this with something a little bit more verifiable. Let's do it by a factor of 12. Like that. Okay, so 5,000 divided by 12. There we go. Bingo. All right, so it is working and it is giving us the correct value. We have the correct factor being applied here. And we have our default unit working as expected. This is great. All right, so now I'm going to do a commit. Let's see here. Let's get GitHub desktop open and open up the Forallpeople repo. Yeah, I'll move it over in just a sec here. Let's see. Why can't I find it? There it is. Okay, here we are. Okay, so what are the changes that I made here? Got it. So this. We're going to get rid of this print. Don't need that junk any there. Okay, save that. Let's take a look. What else did I change? Feeling good about that. Structural.json. Okay, now I put these in here. I don't want those default values in my structural environment here. I also changed how they're in there, but that's also just removing it from the JSON file. And I've got to, yeah, that's the test definitions, right? I put the kilonewton in the test definitions. I'm going to take that one out and put that into now my pound. And then physical helper functions. This is what I changed here, here. Added the default swap logic, a nice little comment with that block. Yep. Changed this into being capitalized title case. Okay, I'm feeling good about this. Let's just clean up this definition stuff. So let's first off take this default stuff out of here, because I'm sure that not everyone using the structural environment wants to use that default. And then test definitions here, I put it into kilonewton, but that I've decided is not how this behavior is going to work. So take out that trailing comma and now put it into instead into pound, which I have it here already, and which is fine. I'm going to save that then. All right, so is that the commit that I want to make? Looks good. Oh, I got this extra line here, 225. I could put that. Do I run this through black? I think so, yeah. So let's just do black here. Black for all people. There we go. Oh no. Oh yeah, that's just the 3 files. That's good. So I was worried that I was behind on my black formatting, but it seems that I am not, and everything is good. If you're behind on your black formatting, then you're going to get a whole bunch of changes that are not related to your commit here. So everything is good. Let's go ahead and now commit this. All right. Feature implemented how default units are calculated in repr template. And I'm going to make a couple notes. Is fixed logic regarding factors, how factors are updated based on the default found. There you go. Great. All right, so that's, now I'm going to finish off with some integration tests here. I want to make sure that this works. So let's just use the thing we already did, the test we already did. We did this. Kip times feet divided by inch. And that should, with the default, should come out in pounds. And it should be that pound there. And let's give this a value D. We just did an independent calc to make sure that that is correct. And let's now document that as a test. And then, oops, run that like that. Oh, what did I have here? Index error. All right. What did I do? I took the default unit out of the environment. So if there is no default environment, okay, so I do need to have a check there for if there is no default, because then it runs into this problem. Okay, so let's go back into evaluate dims and factor. That means I need to do a new test for evaluate dims and factor. I got to update the test suite for evaluate dims and factor now. Okay, so definition. Here we go. Evaluate dims and factor. So what happens if this is this here? Right, I didn't check if it exists first. Okay, so let's do that. if default, like that. So if the default unit is found, in other words, if there's no empty dictionary, now that should be no problem. There we go. And now default attributes, this only gets run if that happens. If not defined and default, we already checked for default, so we don't need to do that check. If not defined and factor in default attributes, then defined equals default. There, that should do the trick. So let's go back and just confirm. Now we've got no default unit defined. Cool. It's coming through again in Newton's, which is the behavior that we expect, which is the original behavior, meaning that there should be no change from implementing this behavior. This should not be a breaking change. This should just be a feature. So there should be no change if someone does not have a default unit in their environment. And it only makes a difference if the default unit is applied to a defined unit. Okay. Let's go ahead now. We got to write test for... Let's run the test suite. And now our test suite is going to fail because evaluate dims and factor is expecting, there we go. It's expecting like it's only getting 2 values coming out, but it's unpacking 2 and there's 3, so there's a problem here. Let's see what else is happening here. Assertion errors. I thought there should be a running error here from evaluate dims and factor. Okay, yeah, evaluate dims and factors was failing. That's what I expect. Test get default unit is also failing because we've kind of updated the behavior there. So let's change that. Right contains one more item. Right, of course it does. Okay, so let's first off deal with this test evaluate dims and factor. So we're saying that it equals pounds and false, and it is not equaling pounds and false. It's equaling pounds, false, and whatever the pass-through factor is, which in this case is going to be 1 divided by this fraction divided by that number. So that's the number that should be coming through, as long and yeah, because that's kilogram meters per second squared. So this, if we have default is kilograms meter per second squared, we've got it defined. So we will be getting a new unit coming through, or a new factor coming through, because that's defined as a default unit in this environment, in the test environment. So we'll leave this over, and then let's go into the test environment here. Oops. Test environment. Test definitions. Now, I've got pound is true there, and let's go to the tests. Let's see what I want to do there. Test... for all people. Test, what is it? Test, evaluate dims and factor. Here we go. Okay, so I'm passing in, looks like newtons to pounds, and then, no, that's a pound mass to kilogram. Then we got this guy here. So this is their acceleration. And now this is whole thing is the factor of pounds, and this should evaluate, let's check it, to this 0.224. So import fraction from fractions, import fraction. There we go, and let's float it. Just so we can see something there. That's indeed the pound factor. So let's write the test so that it actually works here. So this is one test. Assert pound equals false. Okay, so I'm testing here that this behavior works as expected. The pound comes in. The default is set to pound. So I want to change this test to, let's maybe change this to a test of feet. Oh, I've got a test of feet here, so that's fine. It's just that what's coming through is got to be the factor as well. So here's the factor, and let's test that this is what's coming through here on the end. So we got to update all these test cases so that the factor comes through. So now if this is asserting, that's func, oops, what am I doing? Am I doing this wrong? Yeah, this is a whole thing. Assert func this. Wait a minute, what's going on here? What's going on here? This is not an equality test. This is just some bullshit. What is this? What is this? Let's just go and erase this. Yeah, I don't know if you're seeing what I'm seeing here, but I've got no equal sign here. So what the hell is this testing? Okay, so let's go through and update this. So this should be coming through as, so this is a test for kilogram meter. So this is a test for feet. So this should be coming out as, we should be seeing, this returns the symbol and it returns a prefix bool. So this is non-prefixable. So this should be coming out as false. And we should see the factor get passed through, although I've got this guy, geez, maybe I should be doing inch. Yeah, let's do inch because I've got foot defined as a default unit. So I don't want to test that behavior. 1 divided by 12, or I'll just do this. 1 divided by a fraction divided by 12. So 1 foot divided by 12. There we go. So that is the factor that should be coming through. The symbol should be inch. And is inch in my test definitions, test environment? I believe it is. It is. Good. 12 divided by 3 point. Do I have that factor wrong? 12 divided by 3.48. I think it's the other way around. Yeah. This one here is 12. That's how it is. Okay, so 12 divided by 3.48. That's the inch factor. Inch is going to come through. It's going to be false, and then the factor should be coming through just exactly like this. So that should be equal now. Okay, so that's one test case. Maybe I'll just document here. Defined unit that is not a default unit. So derived unit. And what's the difference between these two tests? I literally saw no difference. So this is some bullshit here. That's not telling us anything new. Oh, it is telling us something new. It does. It's squared. It's Newton squared, so it's coming through. So that's testing that. So let's just make it more here. Derived unit to a power. Derived unit, no power, or power of 1. Okay, derived unit to power. And then this one here is our pounds test. So this one is a test for defined unit with a default. So let's make our defined unit here a kip instead, and then it should come through as pound. So we'd be testing this exact feature now. So pound comes through as false. And what is the definition for the pound factor? Let's go up and just grab it. Let's make our lives a little bit easier. Pound, 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 pound. Here we go. Yeah, so that is the pound factor. Okay, and what's the kip factor? Here it is. Divided by 1,000. Excellent. So there's the pound factor, and then we'll just divide that by 1,000. Don't need to copy and paste that, I guess. So divide by 1,000. There we are. And now that should be coming through as a kip, 1 to the power of 1, and I want it to come through as a false, and it comes through as a pound because it set as a default, and now the factor will be this. There. So that changes that. Derived unit to a power. This has no factor. It comes through as 1. Power of 1 comes through. Factor comes through as 1. Defined unit that is not a default unit. Good. The factor gets passed through. And then are there any other test cases that I need to do here? What's this? This is a single dimension. A single dimension base unit, which is one of the conditions in this function that needs to get through, and the factor on this one is 1. And the other one about this is 1, 1, 1. And what is this? Take that out note. That's not useful here. Assert function. So kilograms, meters, seconds. And this is something that's not defined in the system. So not defined environment. And that should be coming through. It's got a factor of 1, so that should be coming through as 1. Okay, so now I think I should only have 1 failing test instead of 2 failing tests. 2 failing tests still. Let's go up and see. What did we miss? La 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 la. 50521. That looks like the exact same number. Assert. Kip came through. No, I'm pressing through Kip. And okay, so let's make sure that I got that right. Did I think about that correctly? Okay, so Kip is what came out of this, and I'm saying it should be pound. And I'm saying it should be pound because a default unit is in the test definitions. Right, but I didn't have the name of the default unit correct. That's how it should be written. Let's make sure I didn't miss any other one of those. Default match case. There we go. Fix it. So it's inconsistent to have lowercase d when everything else I put title case. Now, if I redid this again, would I put these all lowercase? Yes, I would have. However, it is the way it is right now. So I'm not going to make a breaking change and change that. Or what I could do is I could implement some logic so that it did not matter which way. It maybe converted them all to lowercase and worked everything lowercase. But that seems like it's going to be a lot more like housekeeping right now. I don't really want to do that. So I'm going to just keep it as it is. All right, now let's look through run PyTest. 6 failed. Holy smokes. Okay, what did we do? All right, so it looks like things are perhaps working now, working better. And they failed a bunch more tests, which is interesting. So we don't want to fail more tests. We wanted this to just be a feature that does not sort of break anything. But the thing that we're testing here are unit tests of things that are sort of maybe dependent on this behavior but are not exposed through the API. So the end result behavior should be the exact same. And look at that. Look at this. Okay, so this is an exact example of why we need to have a test suite, because this is unexpected behavior that we did not know about just by casually testing in Jupyter Lab, but there is unexpected behavior coming up now that we didn't identify. So what's happening is that these 25 square meters is getting converted into feet squared because feet are set up as a default unit. But I only wanted a default unit to occur if it's, oh crap. I only wanted a default unit to occur if the original, yes, I need to change this behavior then. Here's what I want to do. I only wanted this swap to occur when there is a factor coming in. So that means if default, and I only want this business to occur if the unit coming in has a factor, but it's the wrong factor, or it's a factor that's not found in this lookup. So I want to make sure the factor is not equal to 1. If default and factor not equal to 1. So I want SI units to just pass through this like default use of this business if you are working in SI units. I don't want to have there be any change. So I like the fact that more tests failed. This is great. 3 failed. Okay, that fixed 3 failing tests. So it looks like that behavior might have, that unexpected behavior might have been sort of fixed just from that one thing. So let's see what else failed here. Get units by factor. Okay, evaluate dibs and factors. So let's come back to that. Like that's maybe something else. That's what we're working on right now. But let's look at these unintended failures here. See if there's anything else that we need to do. Get units by factor. So I'm looking at units by factor here. That's just a key change because of the lowercase thing. So let's go into that, change that test. Get units by factor. Def test get units by factor, and this now needs to have uppercase. Let's see if there's any more of those. Default. There's another one, and I bet you that's the second part of the failing test there. Okay, let's do that. Run that guy. 2 failing tests again. Great, we're back to where we started. Now let's go fix the original problem. So we've got rid of unintended consequences. All right. Or we've got rid of the unintended consequences we can see. I'll say that much. But I feel good about my test suite, so I think that I caught them all. Let's see. Assertion, kip, false. All right, so kip is not equal to pound. Correct. All right, so what's happening here? Why am I getting kip instead of pound? Let's take a look. Test definitions. Pound, does it have the default? Yes. Kip, does it have a default? No. Great. All right, so that would cause a concern here. So the default will probably pick the one in the first, like the first match. So if there's two matches, it'll take the first one. So if that had a default, it shouldn't affect it anyway. Okay, so what's going on? The pounds. All right, so we're getting to 5 minutes. I thought I was going to have documentation written here as well. I'm not going to. Probably won't do a video on documentation. I want to move on for all people. I want to move these live streams past for all people. I want to move on now to section properties and this bug that I want to fix in section properties, which is a tricky one. I have an idea about it, but let's finish this in the last 5 minutes here. I think we can do that. The goal is all tests pass. So pound, kip is not coming through. Our pound is not coming through. Why is pound not coming through? So let's just do a print. Let's see. Is it pulling up? Is it finding the default unit? Okay. Now let's run the test suite. And because it's a failing test, we'll get the print statement like coming through here. Oh, here we go. Default. Yes, it's found. So what's the beans here? If default and factor not equal to 1. Okay, so here's what we're going to do. We're just going to go through all this logic and make sure it's all running the way we expect. Print first clause. Print second clause. I'm expecting it to go through all of this. All right. First clause, not hitting the second clause. Okay. Why not? If not defined. Oh, it found a defined. Right. Okay. Okay. So this is a question now. This isn't like a failing test. This is a question of how do we want this to work? All right, so if I intentionally put in kips, I think I want to have kips come out. If I'm working with kips, because the only way for that to happen is if I put in kip. It's only when the thing's not found that I want it to do. Right, so here's what we're going to do. This test should fail. This is the behavior we want. So this should come out as kip. And the factor should get, oops, am I doing the wrong thing? I am doing the wrong thing. There we go, leave that. Test, evaluate, dims and factor, here we go. Okay, so I want this to come out as kips because I'm passing in kips directly with the kip factor. That's the key. It has the kip factor. So define unit with the default, and the defined unit factor is a match. Passes through without swap. Now, let's change the factor. Is not a match. There we go. Passes through, I'll just call it swapped. So now let's change this slightly. Doesn't matter what we change it to, just matters that it's not going to be found. So we've got a force with this incorrect factor going to that environment. It's going to come through. It's not going to find that factor. It'll come through as pound. Again, the value of having a test suite. So what's going on now? Is it the same test? Yes. Okay. Oh, yes, this one. Did I do this wrong? Kip, false. What's going on here? Fraction this does not equal fraction that. Sure, looks like it equals. Oh, this has got more. Did I forget 1,000? A factor of 1,000 here? Yeah, I did forget the factor of 1,000. My bad. Simple typo. There we go. There we go. Let's run that again. One failed. Great. Done. All right, so that's the first one. Now get default unit. I thought we fixed this crap. Default. Oh my god. This looks like it's just a typo thing. Default. Yeah, I thought we... Oh, jeez. Okay. Let's fix it. Okay, done. Okay, done. Passed. All right, let's do the commit. So, tests. Update unit tests for new default capability. Okay, so there we got that. Okay, so I would like to push a release right now, but I'm not going to because we've got I've got the documentation update, and the documentation only gets published when I do a release. So I'm going to do the docs, and I'm going to explain the following: how the default unit only applies to a defined units. So if you put defaults on derived units, it doesn't do anything. I'm also going to explain that it will only occur when a factor is not found, and it will not overwrite your existing units. So I'm confident now from the unit tests that no existing behavior is altered in the user interface experience, in the user experience. So I think this is a non-breaking change. I'm going to do a minor update and bump the minor version, and then we're going to have a new version of Forallpeople today. So if you're watching this later, like anytime tomorrow, then this new version of Forallpeople will be published. So I'm going to update the docs and get it all done. Thanks so much for tuning in, and see me next week for section properties, solving geometry problems, how to what's the thing we're going to try and we got a composite shape, two pieces, they fit together. We expand it, we dilate it, and we want to make sure that at the interface of the two there is no dilation. It only occurs at non-interface edges. Currently, that's not what happens. It dilates at all edges, and you get this weird, crappy overlap, and it's just not good. So Ravi's implemented a failing test into section properties, and so all we have to do is now go and change the behavior of the compound geometry dilation to not expand on the edges. And I've got an idea of how to do that. I've been spending weeks thinking about it. So